Hello, everyone. Um, Today, I'll be discussing or talking about cybercrime and network traffic investigations. And my name is Gabriel Adejuma. Okay, by the way of introduction, early detection of cybersecurity activities, such as attack on the network, is highly important, and they are very, very challenging. It is a challenging task. As recent invention in the technology, allows for manipulation of traffic by impersonation or hiding identity, which makes it very complicated, to track and investigate. Now, investing in cybersecurity by organization is of high priority, is highly imperative, especially in today's world. Now, because we know many businesses are moving towards the internet-based transaction or internet-based systems or businesses where they can transact business using the internet or on the cloud using IoT devices. Now, according to studies, it was estimated that cyber attack is responsible for a loss of about 400 million euros of the total world economy. And the number of cybercrime incidents, as we all know, is on the increase every day. Especially in 2015, it was recorded about 38% increase. Also, researchers estimated that 85% of European citizens believe that cyber security risk is on the rise. We know more transactions are being channeled towards the internet, and many organizations are providing services using the internet right now. And also, however, I would say there are different measures that have been undertaken or different softwares or applications or systems that have been deployed by different organizations to combat these cyber crimes. And in this presentation, we'll be focusing more on some tools, that can help us uh, get information that would be necessary for some of these investigation or analysis. So in this presentation, I have identified three that I'll be talking more a little bit or extensively on. The first one is the Wireshark, and the second is the Nessus, and the last one is the Nmaps. Okay, so Wireshark. Why Wireshark? Okay, the reason why most Wireshark is very popular in today's computing world is because it is an open source and it can work or support all major operating systems from Windows, Unix flavors like Linux, um, even Mac OS supports Wireshark, and that's why they are widely used or deployed on our system. And what does it do? It captures traffic, both incoming and outgoing traffic, and analyze them. So it has a very good display system that or display screen that shows how traffic is coming in and going out. So by that, you can look at the traffic and be able to identify which one is a suspicious traffic or not. And that's why it's very popular. You don't have to pay for for the software for the application. The second one is the Nessus. The Nessus this provide more of a network analytic tools. It's usually based on it only support. Let me say it only support Unix systems. So for Windows servers, the Nexus might not be the right tool to deploy. So, as we all know, most majority of the high-end servers are runs on Unix or Linux or Unix-based system. So that has actually gained the trust of many. The Nexus now has gained the trust of many administrators because if they have to work on the Unix system, they can be rest assured that they have a network analysis tool that supports the operating system. Besides, the Nexus comes in different versions. We have the free version, then we have the paid version. So when enterprise deploy the paid version, they have they have access to support, to upgrades, and also to training. So that is why most Unix administrators or Unix system administrators would prefer the Nexus. So the last traffic analysis that I would consider is the Nmaps. So what is it about the Nmaps? One of the unique features of the Nmaps is the ability to be able to scan over multiple systems at the same time. The ability to analyze or capture data from multiple systems from a large scale of systems, including servers. That is one of the feature or that is one of the capability of Nmaps. It's very scalable, highly scalable. When you bring a new server, Nmaps would when it's configured on the Nmaps configuration settings, it will automatically scan it without additional licenses. And this is another very good tool to use in analyzing network traffic. Now, for my own implementation and suggestion about these network traffic tools, I would highly recommend the Wiresharks. And this is the reason why I would recommend the Wiresharks. Besides that, the Wireshark is free and open source, which means the user can actually configure the Wiresharks and customize it to meet the security demands. That is one of the benefits. And also, I would implement it in such a way that because Wireshark has the ability to monitor traffic on a real time, which is something that is not usually common in other networks, other network analytic tools. The Wireshark, Wireshark has the capability to monitor traffic on a real time basis. So as the traffic is in motion, either in transit, the Wiresharks can capture all the traffic information and store it so that it can be analyzed. And Wireshark can be customized and it's standardized to work with many network interface standards. For example, can work with the Internet, IE 802.11, the USB, and the PPP protocols, and also the token range. It can be customized to capture packets from those interface and standards. Also, Wireshark supports the decryption protocol. It supports many decryption protocol like the IPsec, like the WPA2, web, and the SRKMP, and also to leverage on the security that the encryption provide to provide an advanced security. So most times the Wireshark it allows for viewing and also playback of the traffic. For example, if there's an attack on a system or on a particular server, we could record it with Wiresharks and also play back and see how the activity occurred that makes up the event. In that way, you can give the administrator, the user, the knowledge of how the traffic moved from the outbound to the inbound, and whatever activity that happened, or whatever the file or whatever file that was accessed by the packet or by the attacker, the Wireshark can give a playback on those. So, like I said, one of the benefits is that it's an open source. It can be customized to meet the requirements or the demands of the security. Another tool, like I said before, is the Nessus tool. And how will I implement the Nessus tool? The Nessus, like I said, um, only applies to the Unix operating system, and usually it's not does not really have a functionality of analyzing or um, detecting a suspicious packet on a real time basis. So how is it going to be implemented? Well, the best way to implement the Nexus is to implement it on a passive mode, which is which means it's good for more of the ideas like intrusion detection. You can use it, to detect an intrusion into the network. It has a very good visual graphical tools that you can use to analyze all the packets, and also it can be configured to work with some of the database system for further analysis. For further analysis. Also, one of the most important functionalities that the Nexus provide is it supports. There's a cloud-based edition, so some of the GUI interface can be used from the cloud system. So wherever the user is, you can still monitor the traffic right from anywhere, any location. That is one of the benefits of using the Nexus. However, the command line provides additional functionalities that can be customized in such a way to meet the security requirement and detect all intrusion in and out of the network. Now, the third tool that I will talk about is the Nmap, which is the network mapper. Like I said earlier on, the network mapper is an open source similar to the Wireshark. It can be customized. Um, but one of the things that it provides is it can act as a firewall. It can also act as IP filters, as you can filter out packets or traffic that are unwanted. Then, it has port scanning. You could scan different ports and ensure that you only allow traffic that are needed to come into the network. Then it has some of these command line pinging tool and also have OS detection. Nmap is very portable. That's one of the advantages that it has, and it can be installed on Windows, Linux, and also the Unix flavor. Another thing that it provides is ability to scan multiple chains of network. So if you have servers in clusters all over different geographical locations, you can use NetMap to scan all incoming and outgoing traffic. It has a very powerful uh, user graphical interface that you use to analyze packets and also to perform network analysis. So the GUI is very, very friendly than the command line. However, the command line is more flexible, and you could even write custom program and script and use it along for advanced analysis of the network traffic. So the command line, I would say, is actually better than the GUI. All right, in this part of the slides, I'm just quickly going to touch on some of the network analysis tools, the operating system that it supports, and also provide like a brief explanation on how it's being used. So the first one is the TCP dump. The TCP dump is only supported on Linux-based system or Unix-flavored system. And how is it being used? It's used for packet analyzer for analyzing both inbound and outbound traffic over the network. The window is used by Windows operating system. It's just similar to the TCP dump that we have on the Unix system. In this case, it's used to diagnose the network. It's also deployed to capture traffic and be saved on disk based on certain rules. And you can also do an offline analysis of those captured traffic. We have the net intercept, which is also Windows based. How is it being used? The packets are captured. The tool translate the packet into a more readable text or graphics, and also allow the users to deeply, work to deeply analyze or view the flow of the traffic. Then we have Wireshark. It's used on both Windows and Linux-based operating system. It's a cross-platform free tool. It analyzes network traffic in real time and can be performed best at troubleshooting issues on the network. We have the Convio, which is only Windows operating system. It monitors the internet and the local area network activities. It captures and analyzes network packets. It gathers information about data passing through the dial-up system or the Ethernet card, and it decodes them, and the user can analyze those data. We have the BSNAF. The BSNAF is used by the operating system, Windows operating system. It also gathers all the networks information for statistics. It detects sniffing machines. It filters the network and generates packets using different wizards. It also detects abnormalities in the network, and use the network like DNS resolver, ping, um, and trace a route, to trace how the traffic is moving from one system or one network to the other. That is the work of the trace route. You want to know where the traffic is originating from, and you want to know at every point the destination of how the flow of the traffic moves. We have the MAC-T network analyzer, which is used on Windows operating system. We use this for analyzing and troubleshooting network issues. The Mac Network Analyzer is a tool that captures, it saves, and analyzes network traffic on a DSL or local area network, which is a LAN. We have the Ethernet Detect Packet Sniffer. It's compatible with Windows operating system only. It captures full TCP/IP packet and structure them by the UDP threads and TCP connections with the aid of powerful filters. So, and the packet can be filtered to preserve for most important packet for further processing or further probing of the traffic. Then we have the Etherhead, which is based on Linux or Unix-like operating system. So this is a network traffic browser. Definitely, it's more of a web-based system that displays network activities graphically for users to analyze. It uses the libraries called the libcap to capture the packets, okay, and as a filter. Then it has a genome libraries that is used as a user interface. And of course, it has a simplified visualization functionalities. We have the NTOP, which is the Unix, Linux, and Microsoft Windows. This is a network tool that is used to display the network usage in real time. It uses the web browser to manage and navigate the captured NTOP traffic information to better understand network status. We have the NetSetMan, which is the operating system of Windows. This is a tool network setting manager that can be used to switch between 6 different profiles network, which include the DNS, domain, default gateway, IP addressing, Windows, Win server, then the subnet marks, the DNS server, computer name, workgroup, default printer, and the run script. So what the next man does is it segment. You can use it for different profiles. And what it does is it can capture traffic on those different profiles, even at the same time. And then that is a very powerful tool. So in conclusion, in this article, we've looked at network analysis tool, and how we can capture traffic, save them in different formats like text, graphic, or further analysis. So, and also we looked at how we can implement the Wireshark, the Nexus, and the Nmaps, as a tool that can be used to detect cyber crimes. We talked about Wireshark providing more functionalities for real-time data analysis. And we looked at the Nexus, which is very, very good for, um, which is a Unix-based system that is good for analyzing traffic, both incoming and outgoing from the network. And we said is good to be used in a passive mode, unlike the Wireshark that is better for an active mode. So which means the Wireshark can be active while the Nmaps while the Nessus can be used in passive mode. Then we looked about the Nmaps. The Nmaps in such a way that it is good when we have a very large scale of servers all over the place and you want to monitor from a single interface. The net maps provide a solution for that. Now, the task of the cybersecurity is a very demanding undertaking and needs adequate implementation of the necessary tools. Most importantly, I would like to say that implementation can only be aided by standard policy processes and procedures. When we have them in place, that is when they are only aided. Otherwise, we would not be able uh, to to analyze we will not be able to get the right data for analysis and investigation. So the policies, processes, and procedures they got to be in place. So what happens in this is for future research, we will consider traffic that originate from Internet of a Thing, sensor devices, because we know that uh, recent technology incorporates sensor devices like the home cameras, like fitness equipment for patients with special needs. But, and, and these IoT transmit data via the internet to to the cloud or through the cloud to the server. And there are a lot of vulnerabilities that could emerge from that. So, um, the future research would really, what it's going to do is focus more on the security around these IoT devices and also how to analyze data that originates from sensor devices. Also, another another future work would include using mobile network security application, which is used on mobile devices. They'll be able to analyze information or data that are originating and from mobile devices through the server. And I believe that by the time uh, we're able to put all this information together, we'll have a better security and our system will be more protected. Thank you. If anyone has any question, please let me know. Otherwise, talk to you next week. Bye.